All right, let me hide this panel. There we go. So first of all, if you haven't already, I'm not going to try to find the tab. If you got to go to Spotify for developers, you have to have a Spotify account to do what we're going to do. It does not have to be a pay account, though. So you just, if you use Spotify for free and it gives you ads, you can use that login here. That's how I originally did this. I think during the pandemic, we ended up signing up for Spotify. So developer.spotify.com. I am wondering, let's see if I go to a dashboard or something. I'm asking it to have me log in. Okay, here it says log in. So let me log in. And it remembers me. So if you manage to log into Spotify on developer.spotify.com, let me get back there. Here's the homepage. First of all, they've really jazzed up this homepage to show off all the cool stuff you can do. And this is a wormhole that you could easily disappear down. So don't do this now because you'll miss everything I'm going to say in R. But these are programs that people have made, apps that use Spotify's API and do really cool things. So I guess there's only one example there, but if we went to discover features, it would walk us through all examples of all the cool things that you can do. And that's what I mean by it's a total rabbit hole. You'll start playing around with 6 degrees of Kanye West and then it's lunchtime. So go down that rabbit hole another time. If anyone's interested in creating a standalone app that would run as an app through a website, that's Shiny. That's taking an R Markdown document and making it not just interactive, but making it so you can choose from drop-down menus. Like I want to look at Kanye West's tempo on this album, and then to contact the API and give you the results. So that's a slightly more advanced programming task. The reason I'm mentioning Shiny is for two reasons. First of all, I'll give you a brief introduction to it, probably as one of these modules that I'm doing in the last couple of weeks of class. And second of all, last semester, I had 2 students do as their final project, a very simple Shiny app. That is, they didn't do like a huge geospatial or lyrical analysis and make that a Spotify app. They were just like, let me take this one data set and this one idea. So like everybody knows Blair. Blair made one a few years ago with UN speeches, and they were all online, I think. She got all these speeches from the UN. They were labeled by country and they had all the text. And so you could, from a drop-down menu, choose, let me look at the United States and Russia and look at the sentiment of their speeches in the last year or something like that. And it would generate that visualization. So it's that kind of interactive rather than what we make right now, which is I put in these 2 countries and here are the results. You make it super interactive. All right, I was buying a little time for y'all to sign into Spotify or if you need to or anything like that. So there is documentation, but it's not going to be useful to us because it is language agnostic. That is, you can access this API in JavaScript, which we're not going to do, even though we've seen JavaScript before. I'm going to go to dashboard. I believe that's where we want to go. And we're going to create an app. Now, my page is going to look a little different than yours because I have created 7 apps, although they're all kind of the same thing. So I'm going to create an app. This will give us the keys that we need, like Spotify. This process is much less rigorous than, I'm sorry, I meant like Twitter. It's much less rigorous than Twitter. They'll just give you the keys. So create an app. Okay, we need an app name. So I normally name mine, yeah, like so, this is us. Let's see, 3290 Spring 22. That seems right. App description, an in-class demonstration of using the Spotify API in R. Oops. I will agree to their terms of service and branding guidelines. I guess that's if you want to create something with a Spotify player or something. So as soon as I do that, first of all, this is like bold text says no data available, and it almost reads like an error, but we're all set. Here's the name of the app. Here is the client ID. I'm going to need that. And it says right here, show client secret. Now, I'm not going to click that right now because as we know, that might give us a hard time. That is, we might have to regenerate it, right? So that's the information we need. Now, in the R side of things, we need the package for accessing Spotify's API. It's called Spotify R in one word. If you type that into Google, it's going to correct you. Right? It'll be like, that's probably not what you want. Did you mean Spotify? We did not. We meant this. Let's see. This is actually on his website. I was going to find it on GitHub, but this is fine. Let's see. R wrapper for the Spotify API. So it's on CRAN. You can also see there's a development version on DevTools. We saw the difference between those two things with WordCloud too. Some of us in a scary way. But either one in theory works. Typically they're the same. If you ever wanted to check, you could go to GitHub Charlie 86, I think is his name. So let's see what the version of this is. Is this it? 223? That looks pretty good. I mean, I don't know. Yeah, 223. So I'm going to go over here and just let me look at packages and search for Spotify R, and I have version 223. Okay, yeehaw. If we go to CRAN and go to packages. Oh boy, I wanted to search. Let me go back. Is there an option to search here? Sorted by name, sorted by, not really. Okay, forget it. Let's just assume it's the same thing. So we'll want to install this. So I will do this as a comment. Spotify. Okay, quotes around that guy. So I'm going to say, oops, library Spotify R. And what we have to do is, oh, while I'm at it, let's library tidyverse. So what we're going to do is set system values so we don't have to do this each time. In other words, if we tell our computer, hey, save these values, next time we launch R, we should just be able to load Spotify R and run it. We don't have to enter these keys again. All right, now what these are going to be are the client ID and the client secret. So here's 3 lines of code that are a little codey looking. And by the way, these are straight from the website we were just on. So you could probably copy and paste them. Spotify, bless you, client ID equals, I'll put quotes there. Okay, system.set env, and this is going to be Spotify, oops, client secret equals, I'll put quotes, oops, quotes, yeah. Now I'm going to go over to the website and grab those values and copy and paste them in here. But let me just write out the last bit of code while I've got this open. We're going to create our access token. And that's going to be equal to get Spotify access token. There we go. I'm just going to hit enter there. So in other words, we're creating a variable called access token. That's kind of the default. And it's going to be equal to the value we get by running this function. And what this function does is take your client ID and your client secret, send it up to Spotify, confirm you are who you claim you are, and then you're ready to go. So let's do that. Remember, my numbers will be different than your numbers. But client ID, okay, let me copy that. Ta-da. And let me reveal the secret. Okay. I'll make a little more room, so that's all in one line. So let me try running these. Okay, no error there, no error there. And now the big one, generating our access token. Now, some of y'all, when you do this access token, if it works, it might pop up like your default browsers, like a window, and it might be a login window, essentially doing a web authentication of your Spotify account. So I can't imitate that because I already did it. Did that happen to anybody where you get like a pop-up? Anybody having any errors with it?
I have an error on the access.
Okay, let me take a look. Hopefully it's just a typo. Does it say use that function? Okay, so you gotta load the Spotify. Install. You have to run install packages. Yeah. Yeah, I think it's the same thing. So you just need to go with, and now it should be on the chart. But let's fail. Okay. Interesting. Okay, let's try something else. That's interesting. Can I take a look over here? Let's see. This is how that would be. I had to use it. Do you want to try this? I mean, it's not. Oh, wow. That's very easy. I wonder if that's going to do everything. Let's just check over it at settings. I'm kind of taking over your computer because I'm guessing everyone's going to have the same problem. We might need a redirect URL, but usually they'll need that. Anyone getting that request failed 400 error? No, it's just you.
Awesome.
Let me look it up over here in case that's like a common thing based on like something we can fix really quickly, like regenerating your keys or something. Let's see. Spotify are.
Oh, we got it.
What?
We got
it? What'd you do? Just the same thing again?
I didn't know how to.
Oh, I didn't even look. All right. So is there?
We need to create like an app on Spotify.
Yeah. So you have to create the app in order to get these keys, right? So what I did is in Spotify for developers, I went to dashboard, and you should be able to create an app here.
And what should I put for description?
So for description, I just wrote like they're not going to read it. It's going to get approved immediately. So you could just say accessing the Spotify API in R. That's basically what I said. I said like in class or something. But yeah, they're really pretty lenient. I don't know what the cap is on how many apps you can have. I'm not sure if they have one. What this indicates is that Spotify loves data. They want us to play with their data. They want us to make these crazy apps that they were showing off, right? Like I think if we go to Discover, all these crazy apps do nothing but promote Spotify and promote subscriptions to Spotify, right? And actually our friend Blair, who I mentioned earlier, did an independent study with me and made an app like this in Shiny that worked really well. So let's try, again, I'm just going to stick with the, for a second, the same stuff they have on the GitHub page. That's kind of like a how-to. So I think it's going to be get artist audio features. Yeah. And then in here, I'll type in the Beatles. So just about everything is lowercase. You don't have to capitalize stuff when you're actually looking it up. Sometimes you'll get an error if you type in something like a band name that's confusing. Like I usually use the example of Panic at the Disco because they have an exclamation point. So you just got to try a few different things. Sometimes I look at the Spotify page and see what the URL is in the address bar. This will work fine. Now, I should point out, by the way, if you're like, ooh, I'll do my whole project on the Beatles and Spotify, you can't. I mean, you could, but you're going to be really disappointed because some of their most notable albums are not on Spotify. They were a big holdout for putting their albums on streaming services for a really long time. Not anymore, but I was trying to look at all their albums and then filter out the live ones and the reissues and the best ofs and just be like, all right, let's see, like, you know, Rubber Soul and all the big ones. And they're not there. There's like Yellow Submarine and two other ones. And other than that, it's a bunch of compilations and stuff. So this is just a reminder that Spotify doesn't have everything, even when it comes to really big people like the Beatles. If we click on the Beatles, it's going to create a gigantic data frame for us. So what have we got? Well, I'll blow mine up so we can take a look. Oh, I'm trying to here. Oh, that did it. Okay. A lot of the stuff is going to be gibberish or just constantly repetitive, right? The Beatles album. Okay. So artist ID, that's going to be the same forever. Our album ID, that'll change. Album images, I'm not interested in that, but there are images. Okay, the release date. You'll notice that the album release date for the Beatles is starting in 2022. If we reverse that, it does go back to 63. So this is not when it's being released on Spotify. But you do have to be careful about reissues on albums. Sometimes you have to go in and manually say, no, this was not released in 2010. It was released in 68 or whatever. Here's a separate one for album release year. And so you could access the date, but you could also just access the year, which is usually more useful if we're looking at different albums over time. Okay, date precision, who cares? So I've mentioned these metrics that Spotify kind of invented, but they're all documented on their API page. Danceability and energy, I think those speak for themselves. This is the key signature, I believe. Loudness, again, how this is being measured is kind of confusing. We'd have to look because they're all negative, right? That seems kind of weird. Like if we reverse that, it goes from -27 to -3. That's all negative. That's interesting. All right, mode. I think this is the key mode if it's major or minor. I might be wrong there, but 1 equals probably major or the other way around. Okay, some of these are a little less useful. They're more, I think, for machine learning or AI analysis when you just get like grab 8 billion of these tracks and then I want to kick out anything that's like a podcast. So if its speechiness is really high and its instrumentalness is really low, eliminate it. For us, it's not that useful. I mean, conceivably, you could do a comparison of one artist album by album if they're talking more or if they're playing music more, but probably not. Acousticness really is trying to measure how acoustic sounding it is similar to liveness. So I have difficulty kind of defining these things really beyond the vagueness I already said, because we'd have to go to their API. And they're kind of vague terms too. Okay, valence is the one I emphasized earlier. Let's see what its range is, 0.758 to 0. Okay. It looks like 0.980. So this looks like a scale that goes from 0 to 1. Tempo is literally beats per minute. So that's pretty straightforward. If you know anything about music, you can follow along with this stuff. Okay, track ID we don't care about, although technically every track and every album and every artist has a unique ID on Spotify, and we can use that to access stuff. So if you were to make an app, that's kind of how you do it. Time signature artists, so maybe it includes like everyone that played on it. All right, available markets. So some artists have different stuff available in different places, and this can be kind of interesting. So if we look, for instance, at an international artist like Adele, I wouldn't be surprised if the releases in the United States were different than they were in England. I totally made that up. All right, disc number, duration, so song length, I guess. There is a Boolean for explicit. So if you just want to count how many of this artist, I mean, they're all going to be false for an album that came out in 63 or probably all of the Beatles, right? But if we looked at more contemporary music, how many of these tracks are explicit? If we looked at Miley Cyrus on a per album basis, how many songs in each album are explicit, and does that increase over time? Bam, I got a hypothesis. All right, someone does Miley Cyrus every year. I think I mentioned that every year too. All right, I don't remember what is local is. Maybe that's supposed to be if it's a local artist or something. Anyways, track name, track, yep. Album name, key name, mode name, key mode. So it splits up D major and D major together. So you could look at those however you want. So that is a very data friendly way of creating. It was really easy to access this API. And that's a lot of data, right? So what can we do with it? Let's go back over here, and I'm just going to play around with the Beatles for a minute, and then we'll do this for a few other artists. Let's see. I'm going to do, again, this will be probably the last one we do that's on their page. That is in the demo. Key mode sort equals true. So here's that like last column we looked at. This is not definitive for the Beatles because, again, there are a lot of albums that we would not want to look at, and there are a lot of albums we would want to look at that aren't on here. So it would be inaccurate at this point to say with the Beatles, most of their songs are in D major. Let's see what they have. So I'll stop complaining about this. Let me get this out of the way. And I'm going to go to spotify.com. Might need a little, yeah, okay, let's go to the web player. That's fine. The web player. Okay, let me go here and do a search for Beatles. And let's see, discography. Let's see all. Now we do see all, we cannot, I don't know if we can filter anymore. But okay, this was released in 2022, probably to coincide with that Peter Jackson movie. Let It Be got re-released probably for the same reasons. That's from 2021. We don't want to play with that probably because what often happens on these albums is they'll have like, yeah, they have all these weird remixes of it. You'll get one song 8 times, right? That's really going to mess up our results, right? So look at key signature. It's going to record the key signature for that song like 8 times, right? So we got to be careful. We got to go back. So if we got all their albums, we then have to filter that out. You see what I mean? We're still on the compilations and stuff. I did not see in the data frame we downloaded, like, is compilation true, false, or anything like that. So that's going to kind of limit what we can do. Okay, let's switch bands here. I lied when I said this is going to be the last one from their examples. There is one more I want to show you, which is we can do this for Joy Division. At this point, if you want to type in your own artist, feel free. I'm going to type in Joy Division. Joy Division is a famously depressing band. I think that is why they're being used as an example here, because Charlie 86 or whoever he is wants to show valence. So I'm going to say Joy, and let's say arrange in reverse order of valence. Oh, that was kind of weird. Said, oh, it's showing me the whole data frame. Okay, so let's do a little bit more. I've pre-written this code, so I don't have to think too hard. And let's select track name valence. So in other words, I want to arrange this in opposite order of the valence score. And then I just want to pick 2 columns out of this huge data frame. So let's just pick these 2 and say, what are the 5 most depressing Joy Division songs? Well, we got results, but 2 of them are from remasters, right? I mean, actually, all of them are from remasters. Now, I bet if we look at these albums, they're all going to just be remasters. But we've got a duplication here, right? This is one song that's got 2 different versions. So all the stuff that we learned with filtering is going to become pretty important. Let's see if we can filter this. I'm just going to try it without know what I'm doing. So I'm going to do, before we say head, I'm going to go right before that and say filter and say exclamation point track name includes, and let's see if I can we copy and paste this? Ooh, yeah, okay. I'll get rid of this 2007 remaster. Or I'll try to. So let's see if we run this now, if Passover 2007 remaster goes away. It did. So let's do the same thing. And I'll filter out colony. And eventually we'll get to unique values for everything. Yep, well, another one popped up. You can see what keeps happening. The other thing is we told us to arrange in reverse order of valence. Look at the values. It's 0.946. What if we just said valence? What are the values here? Well, they're 0.038. This is a lot lower, right? So we'd want to look up what is valence. We know it ranges from 0 to 1. My assumption would be 0 would be the lowest and 1 would be the most positive. Is that right? We don't want to look that up. Another thing, when we look at, when I ran this without minus valence, look at it. It's all live. So what does that really say? That means we have to get all these albums from Joy Division and then filter out half of them because there's a live album, there are multiple remastered albums, so it's difficult. Now we're dealing with older artists so far, right? We're dealing with people that recorded it at least like 30 years ago. We won't run into these issues as much as if we get some newer stuff. So let's get some newer stuff. Let's see. Sure. Sorry. All right, let's do this one. So here, let me put a little line in just to indicate we're going to do somebody new. I do not like that new feature. So let's grab Taylor Swift. Easy one. I'm going to again run get artist audio features. That is our really powerful function. There are some other functions that are pretty powerful as well. Oh, I don't want to pipe that. Let me just say Taylor Swift. Now, she is another example of an artist that when we go to her Spotify page, there's going to be like 40 albums on there, right? And she doesn't have that many unique releases. So here we have to, again, filter to only specific song or albums, right? So what if we said, like, just for example, TS and count key mode sort equals true and head 10 and cable. Again, doing this initial analysis will probably show us like, oh, I'm sorry, I have to say knitter for some reason. Like, oh, maybe we made a mistake. So when I said this, what is the key mode here? We've got a lot of G majors, F majors. So can we say the majority of her songs are written in major chords? Well, again, I don't think we can actually say that until we filter down to the 8 or 10 or whatever we're looking at unique releases that she has, right? So what if we did it this way, where we said Taylor Swift and filter. So I'm going to say album. I think it's album name. Album name includes Evermore, and then do that. These are much more certain results, but you'll also see that they kind of flatten out because we're only looking at one album. So we're going to have fewer things. So what we want to do? We want to do filter album name includes, and then put a C here and include all the albums. Now, I think she has an album called 1989, and I'm going to guess that that's a text string. So let's try that. Okay, I have a typo. I always do that. Let's see. I got to put another parens here. There we go. And we're getting results there. Now, really, if we wanted to look at all of her big releases, we'd have to write all those names out. We also need to make sure that we didn't make a mistake. I did 1989 just to make sure that it would grab that as text. Like, in other words, we wouldn't want to do it without quotes around it, even though it's a number. Okay, I think you're getting the idea. What else can we do here? Let's see. Range valence. Let me do one more valence, then I'm going to show you a new way to visualize stuff. So let's see. Y'all ever heard of Waxahachie? Doesn't matter. She has a complicated to write out name. So Waxahachie. So I'm going to say get artist audio features. Her, and at this point you can definitely type in whoever you want. I believe I chose this one last semester because really the only albums that are listed by this artist are the albums that I wanted to look at that I'd heard of. There are on compilations and stuff like that. So sometimes lesser known artists or artists that don't have a ton of complicated releases make things a little easier. One thing that often doesn't show up in Spotify is mixtapes. So if you're looking into hip hop, you know, a whole section of their catalog might be missing. Okay, so what are we going to do with this? Let's say and arrange. I'm going to do it in descending order of valence. I did it last time with a minus. Let's just do it with descending order instead. And again, I'm going to say select track name. Valence and head 10 and knitter cable. Now we haven't really created any visualizations yet, so that's our next thing. So again, it looks like we've got some duplicates. 1, 2, 3, 4. Yep, we got some demos. This is becoming more and more common, it seems. But there we go. That's the highest or lowest value if we wanted to reverse that. Now, let's see. I think we'd write arrange. Let's see what happens if we change descending to minus, if it gets the same results. Yeah, it seems to do the same thing. Let's take that minus away. And there we go, lower valence values. Okay, so let's do something where we actually get visualization. I'm going to say install packages GG Joy. And we're probably going to get a warning that this package has been deprecated, and we need to instead get GG Ridges. So let me say library GG Joy. The GG Joy package has been deprecated. Please switch over to the GG Ridges package, which provides the same functionality. So let me translate what's going on here. It used to be on this package, like all the code that he had on GitHub and on Cran, you could just run with this GG Joy package. We had to kind of port it over to GG Ridges. So let's install packages GG Ridges. No. And library GG Ridges. Okay, so this will allow us to create these interesting density plots that try to show what we'll do is valence over the time of the album, like on a per track basis. It's kind of a confusing visualization at first, but I'll try to explain it. So I'm going to say ggplot, and I'm going to type in my variable for Waxahachie. So whoever you searched for up here, plug in that variable. And then comma, our aesthetics are going to be valence album underscore name. And let's see if this works. Geom Joy. If it doesn't, we might be able to swap it out. And theme Joy. Let's see if this renders an error. Could not find therm Joy. Well, that's a typo. Oh, goodness. Well, it definitely did something. Let me try that again. Okay, I forgot a parentheses. I think I just hit the wrong thing earlier. So let me put a parentheses here where I always forget it. Okay, and now it's saying picking a joint bandwidth of 0.0974. And this looks really weird, but I'm going to click zoom here and try not to obfuscate my code. There we go. Okay, so this worked, but I can see I've got duplicates, right? Here's her latest album, and then she re-released it with 3 new tracks. I got to clear that out, or one of them, clear out the deluxe version here. What are we looking at? Like, what are we actually seeing? What it's supposed to be indicating is that you're seeing the valence for, let's take this first album. We're seeing over a kind of like averaging of the valence of the album over time. In other words, does it get like more or less depressing as the album goes on? And more generally, we can look at the entire kind of blob and see that this album, American Weekend, is way to the left when we compare it to like St. Cloud, which has a much bigger jump kind of on this other side up here. So they're kind of pointing in different directions. It's a little bit confusing to read, so you kind of have to explain it to your audience. Yeah.
What did you do when you left the GM?
Let's see. I think the Geom Joy. Well, you mean this this error where it says you should use Geom Ridges instead?
No, I have an error that says error GM Joy for that kind of function.
Oh, I think you should. If we're lucky, you could just say library GG Joy, because I think you probably installed it and it just hasn't been loaded. I'm hoping. I've got a cooler one of these. Let's see. Okay, yeah, that's kind of cool. Okay, let's do one more. Did that work for you, by the way? Still waiting. Okay, let me help you all out, and then we can try a new one. Oh, I think you probably just a weird shortcut. Oh, sorry. I always do that. That's a no. That's it installs. Yes. Oh, it says GMU is not. Right? Yeah, just that one. Okay, you got one for it. It's because of the spell install. That's all. That's that whole thing is coming to that. So if you run on one side. Yeah. There's an install. Yeah. Everybody else doing okay?
I got like the request failed 400.
Oh, okay. So we have another request failed 400.
After I ran, like,
That's interesting. So it seems to only happen on the access code. So what happened with that before? You just ran it a minute later and it worked?
I haven't spelled it.
Oh, okay. But I was talking to.
forgot I forgot that I didn't spell it.
Oh, that's right. Spotify client, Spotify client. Right. I probably just run those two lines again and then run access with it. Was it working earlier?
No.
Oh, it's never worked. Invalid client secret. So I go back and recopy that. Okay. Well, luckily we're all having really minor like typo issues. So that's good. So I'm going to do one more. I'm going to do Kendrick Lamar. He's got really complicated album names and really complicated lyrics. So he's pretty interesting to look at. We'll also get a lot more words. Get artist audio features, Kendrick. Oops. Lamar. Let me make sure that's lowercase. Great. All right. All right, I'm going to make a crazy visualization of the valence of Kendrick Lamar's albums, and then we're going to have to go back and filter out some of them because there's just a lot more stuff than we need. But let me just get this in here so we can see something cool and have this code. So I'm going to group by album underscore name. And then let's see. Group by album name and ggplot AES. And we're going to do, let's see, valence album underscore name. Here's where it gets kind of weird. Let's see. We saw this, I don't remember what it was for. Fill equals ... x ... Where did we see that? I think it was in early text analysis or something. It's really weird. Anyways, and then I'm going to add a new geometry. So this is going to be geom density ridges gradient. Goodness, that is a long named thing. Okay, so right off the bat, here's what we're going to get. You can see it's a kind of colored version, fills in, bless you. And it lists out all his albums. So the part that I skipped here is the filtering of his albums. So I mentioned some of his albums have complicated names. Like, look at this one. It's got like lowercase and uppercase and periods and stuff. This one's all in uppercase. We've also got some, and this one's all in lowercase with a period. So is that making it easy? What we would want to do is filter out any duplicates that we have. So we have 2 copies of Good Kid on here, 2 copies of Damn. Maybe we could decide whether or not we'd want to include the Black Panther soundtrack. Kind of depends on how familiar we are with it. All right. Now, what I normally did at this point is create a density plot with the words of Kendrick Lamar, but we are not accessing the words right now. So that would be a little tricky. Also, I just want to focus on using Spotify right now. Let's see if I forgot anything. Okay, so we've looked at, let's see, key, mode, but remember, you can also just look at key or mode. So if you're interested in how many of the songs are in minor, how many are in major, we can do that, right? So let's see, TS and count mode sort equals true. Actually, I think mode is just like 0 and 1, right? So there's a lot more ones than there are zeros. Let's see. Spotify API mode. What are you? Mode. I don't see mode on here. All right, let me go back. Get tracks audio features. Sure, sample data, try it. It's not going to tell us what mode is here. We need to find the documentation. Nope, this isn't it either. So let me go to docs. All right, so what are we using? My assumption is we're using this web API. And this is how we're connecting. URI, responses, timestamps. Oh, here's the 400 we were getting. Bad request. The result could not be understood by the server due to the malformed syntax. So it's really just telling, it's a fancy way of saying you have a typo when we get that error. I'm not seeing anything there either. What an oddly undocumented thing. Web API reference. Here we go, finally. Albums, artists, shows. I still don't know which one of these is for mode. Let's look at like albums. No, what were we doing? We were doing get artist audio features. Get artist. That's not quite the same. All right, I'm just gonna disappear down this, I think, if we keep it up. Let me click on Lamar and let's scroll to the right. Oops, not that hard. Major and minor, it's mode name. So let's see. I have not filtered out Taylor Swift's multiple album duplicates on here. So again, these results would be questionable unless I just filtered it down to the handful of albums that I want to focus on. Most of her songs are in major keys. Okay, has that changed over time? I don't know. Could we figure that out? I don't know. Let's say, what if we said group by album name and count, mode name. I'm going to say comma. I bet if we run this right now, we're going to, actually that worked. We've got album name there. Okay. So here are the albums and their modes and a count. So those are really high counts. I wonder if we're getting duplicates of stuff like I was saying earlier. Yeah, we got deluxe version, deluxe. A lot of different stuff. Anyways, we can look at stuff on individual tracks. We can look at individual albums, all that kind of stuff. It could be kind of interesting to look at an individual artist over time. It can also be interesting to compare two artists over time. So for instance, we looked at the Beatles. If we wanted to talk about like, what about like their solo albums or something like that? How would we find that? That kind of, so most of what I search for in here, I'll go to the Spotify website. I'll do a search. And the first thing, oh, there he is. First thing I want to do is see what albums they have. So albums, discography, see all. And so far it looks good. But there are a lot of tracks on here. So it looks like we've got another thing with deluxe going on. Let's see if we go all the way to the earliest stuff. There's plastic. So the more familiarity you have with an artist, the better you're going to be able to say like, well, look, I recognize that this album is on Spotify, but this is not like really, this is recognized as John's first solo album from the Beatles. So I'm going to focus on this one. And then what if we wanted to search, you know, like all of the Ringo Starr, all of the Beatles released their own solo albums after the Beatles broke up in like 1970. You do not have to do your project on the Beatles, by the way. We could analyze like the valence of their first two solo albums after they broke up. We could. Who's happier and who's sadder? Well, my guess is, you know, John's happy with Linda playing in Wings and he's going to have higher valence. And or I'm sorry, did I mess that up? I think I did. Paul is. And John's first solo album is about like his mother's passing away when he was young and the angst and anger they have in the Beatles and stuff like that. All right, now I'm going to go over here and point out that there's some really cool stuff that you can do with these as standalone apps. So what we're mostly doing is analyzing tracks, right? Let's look at a song or an album and I want to see how positive or negative it is. There's stuff that you can create that has actual playback systems. Spotify's API allows you to access their recommendation engine. So that Spotify app that Blair made had you, I believe, upload a playlist, and then it would create a new playlist based on some of the metrics there. Let's just do a couple other examples here. If we said like TS and let's see, if we wanted to look at the, what am I thinking of? Danceability and group by album name. Oops, having some issues here. And let's see, count. I just keep running count. Danceability sort equals true. I don't think that's really going to make sense because danceability is like a value, right? So I don't really want to count them. I mean, it is showing me the danceability here, and it is sorted, but it looks like it's sorted by the number here. So let's just say like danceability or something like that. We get this weird thing. What if we said GG plot AES, oops, album name, danceability, and geom call. Is this going to render? It is, but look how tall this is. It's crazy. So let me, first of all, so we can read it, I'm going to say, and chord flip. We just got too much data here. Let's figure out what we're doing wrong. So we have a ton of deluxe and deluxe version, and there's a karaoke album apparently. And that's all showing up as well. So what do we want? Speak Now, Red, Lover, Fearless. So how would we do this? What we have to do is filter for what we want in this case, because there are more albums that we don't want. So I'd say filter, so album name includes, and then we put a C here and say, let's see, Evermore, 1989. Oops, I got a typo there. Does she have an album called Red? Okay, thank you for the nods. Let's see. Let me click this again. Fearless, Lover, Reputation. Let's do this. Okay. Okay, I'll just take those. I'm probably forgetting some. You know, it looks like we did not get 19, I don't know. We didn't get Red. Red, Fearless, or Lover. I wonder why. That seems wrong to me. Right? What happened to those other albums? Did I misspell them? We know we tested Evermore and 1989. The Reputation worked. I wonder why Red didn't work, or Fearless. So let's take a look and say TS $ album name. Well, so there's a lot of things called Fearless, right? And I think that might be part of the problem. Same with Speak Now. I'm getting a ton of stuff here. So maybe saying includes Red or Fearless, maybe that's causing the problem. I'm also seeing Red in capitals here. Let me just see if this helps. There's Red. What about Fearless? Does that need to be capitalized? Yes. So I'm kind of making this stuff up, but it looks like some of these are case sensitive, contrary to what I said earlier. So now we have it. Let's reorder album name based on danceability and then say danceability. And forget our parentheses again. You know, if anything, I'm consistent, but in an annoying way. Get out of there. All right, let's run that. That is not what I wanted. Reorder album name based on danceability. I wonder why it didn't do it. Because it didn't, right? Reorder album name based on danceability. Okay, what about negative danceability? So I think what's happening here is we've got so many instances of the same albums, right? That it's like compounding things in a weird way. I still feel like even if we filter all these out, we've still got a bunch of stuff. So what I'm trying to show you all is like how we can look at what we've done and just see the results. So I'm going to cut into here and say, let's say count album name sort equals true, and just see what we have. So there we go. We've got 63 instances of Fearless. My guess is that's for every single track, right? That album doesn't have 63 tracks. I want to look up and see how many tracks it has, but we're counting it multiple times. Does that make sense to everybody? So remember with geospatial, I kept hammering the whole population thing when I first introduced it and said, this is the most common error people have. I would say this would be the most common error people have when they're accessing the Spotify API. It's just not going through and making sure that they've only got the particular albums they want to work with. Let's see. So we did danceability. We could swap this out with any value, right? Like what was some of the other ones? Acousticness, I'm not too interested in. How about energy? Let's try that. Okay, we're getting some values here. Again, it's just kind of doing a count here, so that's not really helping. I think what we want to do is ggplot that. So let me put that back together. And I believe comment this line out. Okay, let me see if I screwed that up or not. There we go. It's still not doing it in the right order, but that's danceability. Let's change it to energy. And there's a plot of the energy of her albums. Again, I'm a little confused as to why it's not reordering properly. I'm sure we can figure that out. But that's kind of interesting. Could we did that with a geom call. Could we do that with a geom density ridges 3D, 2D gradient? Probably not. It requires the following missing aesthetics. Why? So I don't, that's a confusing error. I'm just going to undo. I think we can only work with the density plots. I've only done it with the values I showed y'all with valence, and I've also done it with word sentiment. So I think it kind of depends on how it's recorded, right? The different scale. So valence, remember, just goes from 0 to 1. That works really well with a density plot. Something that has a much wider range potentially wouldn't. I don't know how well it is at selecting its bin width accordingly. All right, so again, you can go down this rabbit hole if you want to play around with any of the apps that they've made that are really cool. If you go to our Moodle page, Moodle.com, what is going on? Okay, anyways, normally when I type www, it's there it is. And you go to previous projects, you'll see a bunch of cool examples. Come on, we're in. Taking its time. All right, where are we? 3290. All projects. Let's check that out. I'll check out both of these. Let's see. Well, I can't really see in there. So let me go back over here. All projects. All right. Well, it's kind of the same thing, isn't it? Shoot, what happened? I thought we had a bigger list. Oh, this is what I wanted, is we can go to their RPubs. I apologize. So let's see. Taylor Swift text analysis. No, I'm not seeing one there. Not seeing one there. Where are our final projects? Okay, Pink Floyd. I think that's not his final project, because his final project was on crime.
They're on the tab that says looking for a project idea. There's a link that has everything. Like way at the bottom.
Okay, thank you.
Yeah.
Thank you. Yeah, I forgot about this. This is there's some fun stuff on here. Okay, so there's all of our final projects. Is this where you went?
Yeah.
Okay, thank you. Oh yeah, this is totally what I was looking for. Let's see. So this gets a little away from the specific stuff that we were doing, like looking at a particular artist and comparing them over time. But this was a really smart idea. This guy was managing the radio station here. And so he had a very strong interest in music. His argument is that in the streaming age, songs have gotten shorter because you get paid more. You get paid every time your song plays. Technically, if your song plays 45 seconds, that counts as a play. So what if your song is 46 seconds long? You're going to get paid a lot more than someone whose song is 5 minutes long. Are songs getting shorter in response to that? They are. He actually does these really cool visualizations and shows that, at least in his analysis, there is a downward trend in the duration. It's really interesting. And then he breaks it down by genre and then does a flow chart. Now, he figured out a lot of this stuff on his own, but it's all using a ggplot. And he probably did something similar to what y'all will do and find where someone used the Spotify API to create like a visualization like this, you know? Okay, let me close that one. We have another one, sentiment analysis of most streamed Spotify artists. I believe this is going to use the Spotify data set that's on Kaggle. Let's see. I needed information from the top streaming artists. Rolling Stone came out with an article that referenced Spotify's decade of discovery. Okay, so they used those artists, it looks like. And we've got a sentiment score for them. So that's using lyrics, right? And we've seen all this before. So the question is, do we then get into non-lyric stuff? It doesn't look like it. Okay, moving on. Seasonal mood changes as seen through music was a great idea, but we had really had trouble getting that to work. So this is mostly word count and sentiment. Here we go. So we can visualize. This is probably from the Billboard data set, but I'm not sure. But we could look at danceability. Has the danceability of the top 100 songs increased or decreased? Well, let's look at just #1 album, average danceability per year. It is increasing. That's interesting. We should add a geom smooth to this as well to see the trend line. Danceability by decade. And we know that's hard because we have to break things up. I don't know why we can't see this person's code, but we need to break it up by decade, which gets a little, oh, here it is. Okay, some of it at least. Energy. So there's definitely all kinds of stuff that you could do. The tricky part here is coming up with an idea. And you can see that these examples are going really broad. They're like, let's look at all Billboard hits. Let's look at like all the #1 songs. Let's look at all the songs. We can't look at all the songs, but if we limit it to popular songs, and we can. So how do you limit things to popular songs? The obvious place to start is that Billboard Top 100. But if you're not working with that genre of music, there are different, of course, Billboard listings for different genres, but you could also use other things. I recently discovered that Pitchfork has an API, and I think it's primarily to access their reviews, but it would be interesting to use that programmatically. Oh, by the way, it's only in Python. Otherwise, I'd be showing it to you. But I want to play around with it when I have some time to see, could I grab like, what are the 10 highest ranked albums? Or let me grab all the albums that have the 10 ranking. Or let me grab all the album reviews that have the 20 worst rankings. And let's do a sentiment analysis and look what the common words are. That'd be kind of fun. Again, only in Python. So hopefully that'll give you all some inspiration if you want to do something on Spotify. And even if you don't, like, I think Blair did that Shiny app as her final project in this class with me, and then was like, oh, I really feel like I missed out on Spotify. So she did an independent study with me to do a Shiny app that uses Spotify. So even if you don't feel like you have an opportunity to do it for your final project, it's always something you can come back to. Unlike Genius, this API has not changed in the 5 years I've been using it. So this package isn't going away. All the stuff that we do should continue working. All right, anybody have any questions? I'm going to wrap it up then.